The presentation today covers a working group update on the functional safety standard that we are developing. The group was founded a few years back, and we already published 2 white papers. The second one is actually very much detailed on the data model that will become a language, a standard. Okay? So the whole presentation is quite detailed on how we got there, how we actually developed the data model, and then a whole example of the schema and how to apply it. So the first part is going to be just a short summary of the mission and the standardization landscape, how we stack up with respect to existing standards. Then the scope and the key objectives of when the group was formed and how we are, prioritizing what are the phases that we are covering. The second part is really focusing on the safety standard itself. The language is based on a data model. So the approach that we took to do the data model development, the white paper that we just published in December, and then an example, a working example. So you'll see that we are close, but the last, let me call it 20%, is a big effort anyway. Okay? And then what's next, which is a short summary. Important here, a disclaimer, if you have ever worked on standardization, you know that it's always work in progress. So everything you see here might change. Okay? So it's always ongoing discussion, revisitation of things, new members coming in, sharing a perspective, a use case that was not covered, and so on. So let me summarize first the mission and the key objectives. So this is something you'll see in the first white paper, which was really summarizing the mission and the scope. What we did there, we highlighted the major challenges that we kind of captured the major challenges that we wanted to address. Okay? So the goal out of this is reaching interoperability, traceability, and automation. So the first challenge that we captured is the exchange of the same functional safety data across different automation tools. This is somewhat the easiest, at least for an audience like this. Easiest meaning the easiest to understand. If I want to do FMEDA in one tool and to another, how do I exchange information? The second one is the connection between the functional safety data and the design information. This is especially important for semiconductor, where the design information can be massive and complex. Less so when you are at OEM level, where the FMEDA itself might be much easier, right, at the component level and so on. But so this one came as a big concern at the semiconductor level. Sharing of different functional safety data across operation and work products in the same layer. It could be an FTA collaborating with an FMEDA or a DFA, so different type of functional safety analysis. How do they talk to each other if they need to? Or verification information connecting to an FMEDA, implementation information connecting to an FMEDA. The last one, I always make the same joke here. It came out to be red. It actually is the hardest one. Everybody is concerned about this, is the exchange of functional safety data between supplier and integrator. Because most of the time you have to customize it, you have to redo it, you have to provide additional information. So a lot of people are like, can we standardize it? And then the last one is really traceability of information across the distributed development environment. So the goal here is defining a language that is going to capture and propagate the functional safety data throughout the flow and the supply chain, and then enable these 3 characteristics. Okay, how do we stack with respect to existing standards? So if I look at a picture here, it's a summary. So in the center, there is the IC 61508, kind of the mother of the safety standards. And then there are different derivation or specialization, including the automotive one. So there is already a set of best practices and guidelines defined by these standards. Okay? What the challenge is that we just summarized, what they do highlight is that it's implementing these best practices that is a problem or is challenging. Also, there isn't always a detail of how to do it, but what to do only. Okay? So the goal for us here is to develop a functional safety standard that will allow to have an easier implementation of these best practices. So we're going to be consistent. I mean, that's a goal, at least, to be consistent with these existing standards. We want to be a support for implementing the guidelines with higher confidence. Okay? So just as a connection point, if you think about ISO, the previous version, they had a reference to the IEC 62380 for the base failure rate calculation. So similarly, what we hope is that the standard will be referenced into a version of ISO or IEC as a way to implement safety. Okay? There has always been a collaboration between Accellera and IEEE. Several of the standards that are published with IEEE have been first developed in Accellera and then passed on for publication. The same plan is here. If the interest is there from the IEEE side, we will share once it's published and finished and has gone through iterations in the community. In years to come, it will be sent to IEEE for publication. So a little bit of terminology, kind of summarizing what I already mentioned. What we are standardizing here is the functional safety data. You see it at the center of several different work products or activities, right? So the FMEA, let's say the FMEDA, the verification part, the architectural exploration part even at the SOC level, the FTA. So all of these are different activities that are then captured into the safety case. So this picture is overlapping with the supply chain layer, IP component module system. Don't try too much to map on the ISO 26262. In the first white paper, we actually created a table giving specific examples so that the nomenclature is uniquely defined. But the idea here is that this set of data is used across the different supply chain layers. And so when there is an exchange in between different supply chain layers, it's interlayer. When an activity happens inside the same, so let's say at a component level or at the IP level, there is still an exchange potentially across some of this, and it's called intralayer. And the goal for the data model is to cover both axes. And of course, EDA needs to sit on both axes. Okay? So key objective here, a lot of the time that we have spent as a functional safety working group is to understand each other. Okay? So when I say harmonize best practices, it took us a bit to open up and say, hey, this is what I mean. The other person, yes, 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 nodding vigorously. And then when we started writing things down, it was clear that we actually meant different things, although everybody was agreeing. Okay? So harmonizing the best practices, the methodologies, using the same language. And here, I'm not talking about like a real language. I'm talking to each other and understanding. Okay? We want to make it flexible, scalable. That's really the challenge for us. You define something today, but you know that you'll have to expand it. So how do you make it in a way that at least for a couple of revisions, you don't have to redo it? Okay? And then the key point here is that this data model / language here, the orange part, is in addition to the existing design standards. Okay? So we are not modifying existing standards. We are putting something in addition, very much like UPF did, for whoever is familiar with that, for low power. We are trying to capture the information here in addition to a design standard. So let's see how we started going about the data model development. Okay? So the first step is what I was saying before, defining in a formal way the functional safety. So first, I didn't put that one slide in. The first goal here is the FMEDA exchange. There are several other work products and everything. The target for our first standardization set is about FMEDA. Okay? So what we did is, when I say functional safety analysis here, I'm really referring to the FMEDA. What we did was formalizing the process to do this. I'll joke here because I asked the team at some point, can everybody please describe what you're doing to do an FMEDA? We got different slide set, and one of them, I joked and said, this is a place and route capability. This is not a flow. It had loops to go back. It was very complicated. So that exercise was actually very useful because it showed people that they thought they were all doing the same thing and they were not. Okay? So simplifying that process in a way that was leading to a data model, but also flexible so that everybody could recognize themselves in it, was our first step. And you'll see what came out of it. The second, which came right out of this, that's why this is so valuable in my mind, is the conceptual data model. Okay? Which kind of data, what buckets of data do we need, where are they generated, how are they processed, and so on. The third is really the functional safety language itself, which again, the way we have done it comes right out of the data model, or at least the way we're doing it, because it's not 100% complete. So these two pieces, the conceptual data model and the functional safety language, will go into the LRM, the language reference manual, plus potentially a user guide for how to use it. But this, for example, the conceptual data model, will also capture how potential attributes of the schema are connected to each other, if there are dependencies. So there is a methodology implied in the conceptual data model. But the actual exchange of information will happen through the language only. Okay? So even if you see a very complicated table here, the language is going to be exchanged, not the table. And this was a big point of discussion. That's why I'm highlighting it. Okay? So the conceptual data model approach, we defined the functional safety data. We don't want to provide a reference implementation. There was a lot of confusion on that as well. There was a discussion whether this was efficiently implemented. That's not the goal here, right? Everybody will then implement it the way they see best. This is really a systematic approach to define a language. Okay? So the conceptual data model defines what the system needs to include and not how. All right? So this is not a reference implementation. This is the conceptual set of information to be captured. So what we decided to do was to use an entity relationship model to capture the data model. So I'm going to summarize it here. I'll go one by one so that everybody, when you see it, it's very intuitive, right? It's not rocket science, but at least everybody in the end can follow the rest of the presentation. So there are three basic information here. One is the entity, which is the object data describing the system to be modeled. So you'll see what I mean by that is an FMEDA, is a part, it's a subpart. Those are the entities, example of information. Attributes are characteristics of the properties of an entity. So, for example, for a failure mode, I could say it's a type mission or it's a failure mode size of that failure mode. So attributes of a specific entity. And then the relationship is a dependency or association between two entities. Okay? Now, there is also another concept, which is the weak entity. The weak entity cannot be identified by its attributes alone, but it only exists in the context of another entity. And here is the example. So let's say I have an employer and I have the entity employee, which has a unique identifier and a year joined, just as an example. Okay, so these are two attributes of the entity employee. Now the weak entity is the dependent, okay, that I connect to the employee entity with an ID, and then I have a name, let's say John. Now, this dependent entity doesn't exist unless I have an employee entity. That's what a weak entity is. We will use it to capture the metrics, which are the output of the FMEDA. Okay? So this is how we capture the FMEDA process, the process I was telling you about. So I start from a design hierarchy. Now, this was already a point of debate because in some cases, you know, some people interpret the design hierarchy as a Verilog, like as a real netlist and RTL, something real. But in some cases, this could be a block diagram, a description of your function, right? So starting from this, you do an analysis of the intended functionality, and you derive a functional safety analysis hierarchy, which translated in our common terms are part and subpart. That's where you define how deep you need to go to then analyze the failure modes. It doesn't need to be, and most often isn't, a connection direct to the design hierarchy, which can be instead very complex. So once I have the functional safety analysis hierarchy, I'm going to do a failure mode analysis hierarchy. So how my intended functionality can actually fail. And that gives me the failure mode hierarchy. Even the word hierarchy here was a lot of debate, right? Why a hierarchy? It's because it is parent-child information. That's why we called it hierarchy, okay? Then the next step is to say, okay, well, this failure mode hierarchy, or even for the functional safety hierarchy, which technology is this implemented in? Because I need to start having some metrics put out, so I need some numbers. And I need to see if this is a memory, if this is analog, and so on and so forth, right? So in initial mapping here to the technology element. So technology element here is, for example, analog 5 nanometer, memory 5 nanometer. We didn't call it technology because usually technology is 5 nanometer, right? TSMC 5 nanometer, Global Foundry 22. So we called it element because it's really analog, memory, macros, this, that. So it's very specific. So I can do this mapping here, and I use it, as I said, for the matrix calculation. I can also do this technology mapping at the parts apart level. That's why there is this connection here as well, because this can happen for failure mode or for the parts apart. The next step is also, now that I have some initial metrics, I want to identify safety mechanisms. Okay? So I can have a library of safety mechanisms. If you see in this picture, this is actually outside of my FMEDA, which is this gray box. So some people wanted it inside, like I have safety mechanism for an FMEDA, and some people instead wanted to share it outside, so across different FMEDAs. So in the end, we decided the picture is like this, but I think in the end we decided that it's free. People can put it outside or inside, okay? But for now, the picture is like this. Now, the application of safety mechanisms to specific failure modes to reach the metric is what we call the application of safety mechanisms. The last step is really to look at the, let's say, design under test, our DUT, or the design under analysis, and see how is this going to be looked at when I'm going to integrate it. Okay, so let's say that I have an IP with 100 failure modes. When I take it and integrate it, when I give it to my integrator, it might look like 5 failure modes at the top level. Okay, so those are the failure mode effects. So the mapping between my 100 failure modes and my 5 failure modes at the top level. So this is the process. Now, it's simple when you look at it. I hope everybody agrees that you can do your FMEDA with this. But it took a lot of effort to kind of converge into this simplified version. Okay? Now, the green things you see here are the metrics. They can be for the FMEDA. They can be, and I'm sorry, here we should have said functional safety analysis hierarchy here, because this is really element is going to be the part of the functional safety hierarchy. So I can do for a part, a subpart, for a failure mode, or for a failure mode effect. So there are really different layers where I can define my metrics. That's why I have so many of them. Okay, so now that was step number 1, defining the process. Step number 2, connecting that to a conceptual data model. And this is why this was so important. We took this process and translated it directly into a list of entities into the data model. Okay? So you see here there is a color, like the blue rounded shapes are objects. So this is really an element object, sorry, an entity object. Then I have the gray relationships here. So the gray, I don't know the English name, I'm sorry. The slanted rectangles, right? Those are mapping in between 2 pieces of information. Let me go back here for a second. I didn't mention that these are called all mapping. You see, there is mapping. The concept of mapping is the connection of pieces of information, right? I connect a failure mode to a set of safety mechanism. I connect a failure mode to the technology element in which it's implemented, right? So everything you see in gray are the mapping operations. So you see, we have done trying to be very crisp, consistent in the way we have defined things. So all of these are relationship between objects. And then the weak objects are the one in green, which are essentially the metrics. So each of the blue objects are actually entities here in the data model. I also have entities which are representing the relationships. Okay, so these are all my entities. If you look at them, I have an FMEDA, an element, which is really the functional safety analysis hierarchy, a failure mode, which is really a failure mode hierarchy, technology element. Some are one-to-one, some are, somewhat translated, failure mode effects. And then I do mapping, safety mechanism, failure mode effect, and so on and so forth. Now, the one that is a bit of an outlier here is this design mapping, which I haven't talked about. is when I actually want to connect my functional safety hierarchy here to the real design hierarchy, which, as I said, can be a block diagram, could be the Verilog netlist we heard if somebody went to the morning sessions, right? So this connection is what we call design mapping. And it's a little bit of an outlier because the design hierarchy is not part of the data model. So this relationship is really not between two entities. Okay, so it's a bit of an outlier. Okay, so the good thing is there is a direct traceability between the process defined and the data model derived from it. Okay? So then the last step is really the language. And the part that I think is very important is that, again, we are following the same rule. We are creating a very clear traceability between now the data model and the language. So when you look at it, the language is really the implementation of my requirements at the beginning. So I'm not familiar with the model-based system engineering, but I showed this presentation to a person who is and told me that we are essentially following those rules here. Okay? So the way we derive the language, so first, you see it's an annex in the white paper, is because it's not final. We needed to have a language to start doing examples, so we have a draft in the white paper, but this is what we're going to work on right now, is finalizing it. Okay? But the way it's derived is the following. So the objects are created with a create command, and if I need to update it, I will have a -update option in the command itself. The relationship are created with an assign command. And then the weak objects are assigned a value with the define commands. So now I could in theory take my table and with the script generate my language because I'm following very precise rules. Okay? So we've done a lot of work at the beginning. Hopefully it's paying off in terms of, how do we then derive the language and validate it as well. Special rule, as I said, for the design mapping, because it connects objects in the data model to objects in the design hierarchy, which are not part of the data model. The original purple box here. I'm connecting to an external object here. And so the design mapping connection is described through the dash mapping and exclude mapping option inside the design mapping relationship command. So it's the only case where we don't have a one-on-one, because we are connecting external to the data model. This is a summary of what I just mentioned, but it has the command names, right? So create FMEDA, create element, create failure mode, and so on. Assign safety mechanisms to failure mode, assign failure mode effects. This is the exception I mentioned, and then these are the define commands. And I kept it generic here, so it's ISO and IEC. So we're not creating a command for each of the layers, remember parts, apart, failure modes. It will be inside the weak object as a type. Okay? So, use cases that we are developing here. One big discussion was the configurability. Okay? So, we decided to keep it, simple for the first version, and it isn't simple even in that case. So the first is really what we called an FMEDA evaluation. Even around this, there was a never-ending discussion. Authoring, evaluation, depends, right? But the goal here is really to exchange every piece of information you need to regenerate an FMEDA. So talk about two vendors. I have a script. I can take from vendor 1, give it to vendor 2, and the vendor 2 can import it and generate an FMEDA for me. So that's the FMEDA evaluation case. For that, you need every single piece of information, every methodology, assumption, everything that you have selected to generate the FMEDA to be exchanged. Even your sizes of your design, everything, right? The second use case is as is. And so the request here is, well, I give you the equivalent of my Excel with some information plus my metrics. You take it and use it, but you're not regenerating it. I don't give you all the information to regenerate it. So I might not give you, for example, the way safety mechanisms are combined, and we'll see an example. So you might not be able to take it into a tool and just read it and redo it. That's not the goal. The goal here is integration and not sharing every single piece of information. Okay? Which is what you do on the Excel today, by the way, right? Because the Excel has several tabs which are somewhat the entities if you wish, but not all are necessarily shared. So that's the idea. We kept it simple. We said, okay, the configurability, we'll worry about it in the version 2 if needed. There was a point of discussion which is worth noticing here, because if you think about it, FMEDA has both inputs and outputs into the same report. That's okay. Now, when you start translating it into a language, what you're doing is you're putting input and output information in the same file. It's like having an SDF and a report timing in the same file. It's usually not done in EDA. So this was a conceptual, controversial discussion if I should give the input and the output into the same file. It's still ongoing, but as of today, the group decided to have everything in one single file. And I don't know if somebody understands the pain of this. I hope so. This has been a very, very controversial discussion. Okay, so summarizing the traceability of the data model development. So we started from the function safety analysis process formalization. Then there is a direct consistent mapping from the process to the data model objects. Remember the blue boxes, green boxes, and gray mapping. And then once we have that, there is a direct translation from the data model to the language with very specific rules. As I said, you can write a script to generate the language itself. So we have traceability. The requirements are the FMEDA project objects and mapping to the implementation of these requirements, which is the function safety data model, and then the language commands. Okay? So this has been the criteria we followed to develop this data model. So what did we put into the white paper? First, so we published it in December. It's 120 pages, something like that. So in itself is scary. Okay, it was scary to us as well, believe me, when we had to go through the review process and everything. The first 30 pages are everything I just described, okay, and how to get to one to the other and so on and so forth. So that's 30 pages. That's the main body, right? Also, it contains the associated methodology discussions. So I'll give you an example that was also a source of entertainment. How many, so the ISO, usually you see the FMEDA examples, they have part, subpart failure modes. The requirements from a set of members in the team was, no, I want several layers of subpart. So I could have a part, subpart, 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 subpart failure mode. Big discussion. That's not the goal, right? You're describing the intended functionality, not a design hierarchy. The other problem when you do that is, well, now what if I have a safety relevant subpart that is contained by a non-safety relevant subpart, and how do you nest all of this consistency? Okay? So these are the kind of methodology discussion that came about when we were doing the data model development. Those are those that we need to finalize for the LRM user guide, because we have a bunch of them captured, but they are not all of them. Okay? So the annexes are the detailed data model. I'll show you what it is. The prototype language, what we're going to do after this version, and then the repository and of examples. So the annexes, which are probably something like 90 pages, are the ones that are to evolve into the LRM user guide. So the white paper itself is really 30 pages. Please read it if you have a chance. The rest of the annexes is what we are now translating into LRM user guide. Okay? So these are what I was saying before, right? Data model, language, annexes. You see it starts from page 33 something. It goes up to 120. Okay, so let's look at the detailed data model. I only took a few screenshots here to give you the sense of what really it contains and the type of information that has already gone in. So let's say, the first entity is the FMEDA. We also put what is the key identifier. Why? Because when we have this list of entities, you need to know how to uniquely identify an object. You remember it's in hierarchy with parent and so on, parent-child. So what we described is, how do I know where this object sits? And you'll see this one is simple, right? It's just the FMEDA, which is my name, which is my unique identifier. So I can't have two FMEDAs in the same data model with the same name. That's what it means. So then I have the dash type. We define the type of attribute, whether it's a string or, for example, an enumerate or a float or whatever, you'll see it. And also what are the ranges. This is really not so much specific for the data model. We'll need this for the LRM. So you see, most of the work is already done. We're now validating that everything is consistent because we made changes on a lot of things. We introduced the concept of assumption-based and calculation-based, which really means whether you are connecting your information to a design hierarchy or if you are inputting it manually. Okay, so we'll see. Maybe I think I have an example later on. Then I have the ASIL and the SIL for the IC. And then the enumerate goes from A, B, C, D or none, and same here. Now, the other piece of information here is what is required. What's the meaning of required? We had two options here. Required to do an FMEDA or required for the parsing. It's two different things because when I have an enumerate, I can have default values. So it's not required for parsing because I can use a default, but it's required to perform an FMEDA. So that's the other discussion that went on. You'll see it in some other slides. The other thing here, these are all parameters that you'll see now that we started from the high-level entity boxes. Those are not changing. We're keeping those. But this list of attributes is what we are refining. We might change the name, we might remove an attribute, we might need to add one if we don't satisfy all the use cases. So that's the work we're going through now, reviewing the details and see what is needed to cover all of the use cases from the members in the working group. This was added later on, and interestingly, this hierarchical, we haven't created a lot of use cases, so there will be work to be done. We also have space for user-defined attributes, which are more property of the language rather than the data model itself. Okay, other example, element. Now this is interesting because this is representing the functional safety hierarchy, the part and subpart kind of thing, right? So we had to make it generic because we have, first of all, that multiple layers, parts, subparts, and then we also want to support IC and ISO in the same time. So we have an element name, the description, which is optional, and then the element type. It can be a system, element, sub-element, component, subcomponent, part, and subpart. And you'll see that some of this is focusing on semiconductor, but sometimes we try to extend up to system level because it's our final goal. So we have situations where we had a long discussion, we extended to the system level, and then we realize, well, this is extended, but not the rest of the data model. So we have to make a decision. Do we keep it, or do we restrict to semis and then extend, right? And here, the key identifier is the element name plus a parent element. That's why it's a safety hierarchy, because I can define multiple layers, plus the FMEDA name, right? So to uniquely identify an element, I need these three pieces of information. So inside here, I will also have a parent element. So if this is connected to an FMEDA directly, so it's my first level subpart, this will be empty, but otherwise it will have another connector. All right? So that's how I'm recreating the uniqueness of these things. So an element only needs to be unique in the context of its parent, and I'll show you an example of that. Safety mechanism, very similar kind of attributes here. I'm not going to go through each of them, right? But here there were other interesting discussions, and I want to capture it because I made a statement before, which was not everything is captured in your FMEDA table, in your Excel spreadsheet. So here, for example, I might have, actually it's not in this one, but you see that I have a DC here, DC permanent, transient, and latent. This is going to be the safety mechanism diagnostic coverage in isolation. Most of the time, this comes from ISO, the high, low, medium kind of thing. So it's a safety mechanism. You haven't applied to anything. You don't know what the real coverage is in real life. But in theory, it's a high, or it's a low, or it's a medium. Okay? So this information is the safety mechanism in isolation. So now, when I map the safety mechanism to the failure mode, I have now additional attributes here where I have the DC, let's just look at a permanent. I have an estimated one and I have a measured one. So the estimated one is the one that connects my safety mechanism to the failure mode. And then the measured might be, for example, after fault injection, right? So I have to start taking all of this into account not everything is going to be shared with your customer necessarily. For example, if you have 2 safety mechanisms assigned to the same failure mode, your table would show something like failure mode 1, safety mechanism 1, comma, safety mechanism 2, and then you just have the cumulative DC. You don't have all of the isolated ones. You just have the combination. How you got there, it's your business. Here, we are also giving you a way to combine them with some heuristic or with your own expert judgment. But the point is, if I don't tell the receiving end how I did this, they won't be able to recalculate it automatically, right? So the as is versus the evaluation, remember that there is a difference on what you share, what you actually need to calculate an FMEDA metric. So what I do have here is an example, okay? So this is a block diagram. This could be a Verilog, okay? So this blue stuff is an example of a design. Now the first step is I have my design under analysis, and then I do the analysis of the intended functionality. And this is my functional safety hierarchy. It's color-coded for a reason you'll see later, but you see that some is being collapsed up, right? So for example, the CPU, I collapsed everything, all of these 4 blocks into Mac or non-Mac, just as an example. And then the MMU here is collapsed everything here, and all of this hierarchy down here is all collapsed up, right? So the way it will look like in your Excel spreadsheet is that you have a part which is top, and then the subparts, all of the colored one, right? So the Mac, non-Mac, the MMU, DC FSM, DC tag 0, DC RAM. So all of the colorful one is where I stop my function safety analysis hierarchy. Okay? And the way the language would look like is this. I create my FMEDA. I create an element dash part top. Question could be, hey, why don't you start from top and so the rest is part instead of subpart? That's possible too. It doesn't really matter. It's really the concept, right? So I create an element which is a part, which is top. I'm reproducing this here, right? Create an element dash type subpart Mac dash parent top dash FMEDA my FMEDA. So let's look at this. Mac, the parent is top directly, right? And then top connects to FMEDA. And then the rest is really the same concept. Remember when I said I need a unique identifier? That's how I'm creating this Mac, top, my FMEDA. Okay? So then I'm creating the failure mode hierarchy. Okay? These ovals here, or rounded shapes, are the failure modes. The color coding is that these failure modes belongs to this subpart, this to this subpart. So the color coding should be helpful here. And so what I'm doing is look at your regular Excel spreadsheet. For Mac, I only have a failure mode, which is failure mode Mac here, 1, right? And then I have a failure mode non-Mac, just 1 here. For the MMU, I have 2 of them, failure mode 1 MMU, failure mode 2 MMU, right? So, simple. And then the language here would be create failure mode. Let's look at just one. Failure mode 1 DC RAM, which is whatever, this one. Dash type mission, it's another long discussion there. Dash parent top DC RAM dash FMEDA my FMEDA, okay? So we had to do this to create the multiple level of subparts. And it's somewhat starting to resemble a design hierarchy, although here it's collapsed. But all of this, we never discussed the fact that there is a dot. That in itself is implying something which we have not discussed yet. The type mission means that all of these are affecting the safety goal directly because these are all, your intended functionality. We haven't seen safety mechanisms in here yet. The type mission is also in discussion. Okay, as of today, actually. We are creating examples to see, do I really need it? Can I use another? Does it cover every use case? So now I'm creating a technology element first, and I have 2 of them. I have a digital 5 nanometer, and then I have a generic RAM. It doesn't really matter. It could be anything you want. So the way I do this is I create a technology element. The name is digital _5N. Dash type digital and that's the failure rate. So this is the base failure rate. There is a whole way of calculating which is hopefully consistent with ISO. That's also in the white paper. I'm not covering it here. And dash type digital, it has implications of how the size of the failure modes will be interpreted and used. Okay? So some of these attributes, I'm just giving examples here, but they have implications of how they will be used. So most of the attributes have implications, otherwise they're just for information. It's not very useful. Okay? And then the second one is create technology element RAM dash type RAM, failure rate 1e-5. So now, when I assign a technology element to a failure mode, so let's say failure mode Mac, so I'm looking at this one here, I'm assigning and saying this is covered by digital. By the way, you can assign more than one technology element per failure mode. That was another request. There is always a trade-off between complexity and flexibility. And the more flexible you make it, the least checks you can then apply, or the more complex the checks that you apply become. So it has been a lot of balancing between the flexibility. Of course, all the users want all the flexibility in the world, but most of the time there is then a price to pay. So the idea of having multiple technologies for a single failure mode has implications when we do the matrix calculations and the reporting. So anyway, so let's look at this example here. I'm looking at this one and I'm assigning a digital 5 nanometer to this failure mode. The parent, again, every time you assign two objects, you have to identify them. So the technology is very easily identified. It's not connected to any FMEDA. This is outside, right? This technology information lives outside of an FMEDA because I can do, 10 FMEDAs with the same technologies, right? It's just a description of the base failure rate. So this sits outside of the FMEDA, and that was also in the process. Remember the process flow diagram, right? And now every time I define a failure mode, I have to give the full path. There is also another information here, which is the failure mode size. Okay, because I need to be able to start calculating the failure mode distribution and the failure rates of the residuals and blah, blah, blah. So in this case specifically, I'm assigning a failure mode size. We started from the blue stuff, which was a Verilog. So you'll see how we then connect to Verilog. But even with this, I can assign as a user a number here. What it means, there are a lot of details. But the point is, I want to make an important distinction that when you assign a size, it doesn't mean it's inaccurate. It just means this comes from the user, which could be as accurate as when it comes from Verilog. You could have done your own scripting and assigned it. There is no implication when I say I'm making an assumption that there is a relationship to accuracy. Okay? So here in the table, this is what I would see in a regular FMEDA. I have my part, subparts, failure modes, the type of technology this is mapped to, and what's the size. Let's look at the MMU failure mode 2 here. You can see it has two technology elements, the digital and the RAM, and therefore I have two sizes, the one corresponding to digital and RAM, because then my metrics are calculated by technology, right? So here I need to do two assignments, assigning a technology element to a failure mode, the digital to this failure mode, MMU, parent, top, blah, blah, with this size. I do the second assignment, which is the technology element RAM to exactly the same thing, except the size is now 25. Okay, so this is just a summary of what I was showing before. Now, because I want to do design mapping, so remember the purple box outside of my FMEDA, which is my design hierarchy. Now I want to do the design mapping. So here I have assigned my failure mode size manually. Now I'm going to do the connection. So if you remove the color coding, this was my original design hierarchy, all in light blue. This is my functional safety hierarchy. And now I did the color coding by saying, hey, the non-MAC is all of these three blocks under the CPU, and this MAC is this block. The DC RAM is here. So it's just one block, but I collapse it up here. The DC tag 0, I'm going to go down here. So this DC RAM is going to be summarized up here. Okay, so the failure modes might be higher level, even though it's just one block. So then the MMU here, it's all orange, it's going to be all of this. And I didn't do the color coding below because it's implied. But if you wanted another representation, this could be all orange, okay? So then, we're going to spend a bit of time on this. So now I'm going and bringing back again the failure modes. Okay, so this was easy because I'm mapping parts, okay? Now I go here, right? And that's why actually I wanted to specify here why I left it in different colors. You'll see it. So now I brought back the failure modes with the color coding. Now let's look at one simple and then one more complex. So for the Mac, I have a failure mode Mac. It's digital. And now I am mapping to my Verilog. Let's just call it Verilog, right? So top CPU mult_Mac. Top CPU mult_map. So I've taken my function safety hierarchy. This I could have called mom. It doesn't matter, right? So this is completely arbitrary. This is the blue stuff. Light blue is the Verilog, okay? So here, the multi-Mac is, the failure mode Mac is here on this block. So this is my failure mode design mapping. I could have done it at a part as well, okay? So this is for the failure mode. So now here's the interesting one. The failure mode MM2 here. You see the failure mode MM2 is at the top here, but then the failure mode MM1 is here. So I need a more detailed mapping and a dash exclude. So I'm going to define my failure mode MM1 here. It's top LMMU, this, right? I go down here and it's these two blocks. You see it's the RAM, the MR RAM and TR RAM. These two blocks map into this failure mode 1. Okay? Now my failure mode 2 is just the two tops, so these two. Everything except, exclude these two blocks, which are actually this. I'll stop here for a sec because I don't know if I explained it properly. Okay? This is really the sticky part. This is why at the semis there is a lot of discussion. Handling the design hierarchy. How to map it into an FM EDA, that's the sticky part. That's the part that EDA can help with. Okay? So the mapping here connects to specific Verilog blocks, and then you have a design exclude so that you can say everything except this, instead of having to list manually everything else, doing the difference yourself. So here is the next part, which is, if you remember, we had defined this failure mode size before, and now I have done the mapping. So now where do I take the information from? Right? So if you remember, I had an attribute in the failure mode, in the FMEDA itself that said assumption-based or calculation-based. Okay? So that attribute tells me if it's assumption-based, the precedence among these two attributes is with the failure mode size. That means I'm giving precedence to information given by the user. If it's calculation-based, then the precedence is here, extracting directly from the netlist, even though the user has given me something manual. This was different the way we started. We said, okay, whatever the user gives me, it's always taking precedence. Otherwise, why would the user do it? Then there was an objection that said, hey, but maybe I start with an assumption, but then I want to refine it. Are you asking me to delete everything I already inputted? So these are the kind of discussions that are going on, just to give you the sense of how detailed until you get to a complete language starting from scratch. Okay? Now, this is everything, right? For a very simple example. So this becomes clearly very long. We have seen a lot of positive feedback in terms of people used to EDA, for example, IP provider or semis, that do this on a daily basis. I'm not sure that for people that are doing this at the tier 1 level, this will be very intuitive. Okay? So one effort we're doing is creating this user guide of examples where we show both the Excel table and how it would look like here. In some cases, for some user, this is going to be just generated by the tools. They don't care, and that's it. For some other cases, this is going to be people writing it, and that they're very happy about it, and that's what they want. Okay? So I'm not sure if there's anybody here that is not like a tier 1 or a tier 2 or an IP provider, but we have seen interesting reaction from people that are doing an FMEDA, and they are like, but I liked my Excel. I mean, that was easy. It was easy to see graphically, right? And then we have all of the problems of importing, interpreting, and so on and so forth. But I can also see that people that are not used to scripting, that this can be, kind of scary. There is a discussion also around the format, whether we keep it at like this pseudo language level or whether it becomes maybe more formal, like a JSON or an XML based. We don't know yet, but most likely this is staying at this format because it's kind of very descriptive. It's more intuitive for a lot of people, but it's not cast in stone. Okay, what is next? So we're going to publish the LRM and user guide. Of course, everybody then asks when. We're hoping that the first draft of it is going to be this year. Actually, let's say 6 months, but it's an attempt. We've been working on this for really long, and you see the kind of detailed discussions that are going on behind the scenes. So the LRM is usually just the description of the language plus some of the rules. So if you're doing parsing, right, there is a command that has an option. That option is connected to another option, another command. So let's say a safety mechanism, it's defined as non-configurable. Then when I assign the safety mechanism to a failure mode, can I say configured yes, on or off? Well, only if that safety mechanism was defined as configurable before. So there is dependency when you do the parsing. And I'm sorry, I call it parsing instead of semantic checks because it's really what it is. When you do the parsing, you see whether it errors out or not. What are the rules to be followed? Okay? So really, the validation we're doing right now is making sure that we can go top to bottom to do an FMEDA. That we know we can do. Okay, we already have an example that does it. Now, all of the corner cases, I'm assuming there are vendors inside the room, at least I know of 1 or 2. Start thinking about regression. We have like 10, 15 commands, and each of them have different attributes. We have to test all of those attributes. Either you do it with the tools or we do it, during this validation process. When I define something, what's the impact on all of the other commands? Okay, so that's kind of the effort we're doing right now. Also, we have a few examples. Is this covering everybody's methodology? Is Infineon, Renesas, NXP, Qualcomm? Is everybody doing FMEDA in a way that can be captured by this data model? So that's what we're doing right now in terms of validation. We are creating more detailed examples, cleaning up when there was a parameter defined, how is it going to be used? Why did you find it like this? Because this was maybe 2 years ago. So that's the cleanup we're doing. And Edmond, to your question on the failure mode, where can I define it? That's one of the use cases that we're going to capture here. Okay? It's one of the things that we need to remember to test. We are also checking on, is there a formal way to do this? Because we have a schema. So far, we didn't really have a lot of luck, but we're trying to learn from previous examples. Like, I'm checking how has the UPF team validated UPF, for example. Can we do it in a formal, exhaustive way rather than us testing manually all of this, right? So anyway, so that's what we're doing. And so the user guide is kind of the outcome, hopefully, of this validation. We are making assumptions here. The language part, I didn't finish discussing. This one I mentioned, whether it's going to be formal or a pseudo language, potentially even details of implementation are coming up. Single or different for different use cases, so the authoring and the exchange. There was one of the discussion was, hey, this idea of having input and output into the same file is pure ugliness. Why don't we say for the authoring, see the leftover of not correcting, this was called evaluation in the other page. So in the evaluation case, we have a tickle looking like, and then for the exchange is JSON just with the metrics, for example. That wasn't very well accepted, but it's, we'll do a ballot and everything. And then the usage of default value, when we discuss with the team, shall we use default values or not? The decision has been no, because for safety, we want everything explicitly thought through. That makes it for a long list of attributes for every command. So It might be that as we go through, people realize maybe the default values weren't such a bad idea, or it might be that we keep it and we don't use default values. Okay? So, version 0.1 is FMEDA semiconductors. Hopefully, we make it in a way that it's extensible. Post version 0.1, language features, hierarchical support. We might actually pull in the hierarchical support. Version 0.2, safety goals, extension for verification support, FMEA, system level, all of these things are on the table. We might extend the safety goals directly here. There is a reason why we postponed it. There was a separate discussion on requirements, but we might pull it in because it's really needed for the FMEDA metrics. The extension for verification, it isn't just as simple as saying, these are my diagnostic point, my observation point, because when you start the discussion, people will start asking you to standardize the way not observable, not detected for all the simulators. That rattle is starting if we start that discussion. So I think we'll do it in phase 2. What is not listed here is, for example, and we were having a discussion with Francesco before, is the implementation side. Do we need to standardize that too? Yes or no? That's another discussion there. So this is kind of the what's next. I wanted to explicitly mention what is it that is a language feature only. So in this Annex C, we did this add-on to the version 0.1. And what I circled in red are the language extensions. These are not really contained in the data model, so the conceptual concept, but they might be useful for the language. So an example, SLF is a standard language format. It's just something we came up with. It's not going to be the final extension. But load SLF, save SLF, add parameter, which is a completely custom way of putting pieces of information together, attribute expression. So all of these are language facilitators, but they're not part of the schema, right? What you see here is instead how to enable a hierarchical or an SOC FMEDA. So these commands, we didn't include into 0.1, but we listed them because some discussion was ongoing. And so we said, let's not throw away anything. Put everything in the draft annexes, and then we'll revisit. But the idea of saying set scope this specific FMEDA, that means when I set my unique identifier, I don't need the dash FMEDA at the end of every command, for example, right? And then the assign FMEDA to FMEDA is a way to group IPs FMEDA into a SOC FMEDA or blocks into a top level, right? So this way of combining blocks, and then this is another way of combining blocks, whether you are combining IPs or whether you are combining blocks. It's kind of two different ways to do it. But these are all draft high-level commands. We haven't really done any examples or anything, okay? Okay, so that's the end of the presentation. There is time, hopefully, for questions if you have any. The white paper is what we published May 2021. This is really describing the mission, the scope, and you'll find much more information of what I shared at the beginning. So it also shows, for example, that there is a system level, a software, analog, mixed signal, blah, blah. So all of the things and where we're focusing. And then, you know, what is higher priority for us. And then the challenges, they were described in a lot of details there. And then the data model white paper, this is what we published in December. That's what I was talking about, the 120 pages. Hopefully this one makes it into the archives of DVCon. Or if you go on to the Accellera site, it will show up in the function safety activities. You'll see this because it's quite recent, right? So these are the 120 pages I was talking about. And then this covers the methodology, and then all of the annexes that we are working on refining to create the LRM and then the user guide. So I'll stop here if there is any question. Otherwise, I can go and talk forever on a set of slides anyway.
My question is, with this language,
I think it's, I don't know if the others can hear you.
Yeah, nice presentation. So with this language, is the idea that I can write in this language and execute the forward campaign with any vendor tool once vendor starts supporting?
This language is focusing on the FMEDA exchange. not on the fault campaign.
Okay.
Okay. Now, let me see if I go back for just 1 second here on So here, when I'm defining the failure modes, so the failure mode itself, okay, this is the element. Sorry, I think we add a failure mode, no? We skipped it because it was too big. Okay, so here you see, if you remember, I said I have a DC estimated, and then I have a DC permanent, right? So in here, I'm only providing the hook for back annotating from the safety campaign, for the fault injection campaign. However, I don't have it here, but in the failure mode, at some point we defined an extension for a diagnostic point and observation point, so functional versus checker, right? So that extension was in the first version. Then we removed it because this is really a hook to the verification part, and also here. So that's another consistency check we'll have to make. But the goal here is to provide a way to annotate back in FMEDA. Okay? This is not a definition of the fault injection campaign.
Got it.
That might be a second piece, which is a standardization more on the verification side. This is FMEDA centric and the hooks to other work products. So it could be the fault injection. It could be even, that's why we postpone the safety goals. It could be even a connection to safety requirements, like to your JAMA or whatever. Because right now it's a JSON exchange, right? It might be good enough, or it might be that we need something. So one discussion, that's why we excluded the safety goals, was, hey, do we want to just define the safety goal as a name, or do we want to actually provide, for example, a connection to an external way to track safety requirements? So that discussion wasn't completed. So I think what we're going to do is just simply put a safety goal with a name. Okay, but this really, if you think of that picture that I showed at the beginning with all of the work products, we are really focusing on this first part here. But you see then there is the connection to the functional safety verification. Now, we could focus on this connection, or we could focus on the whole thing. That's a discussion for the group to decide. Okay?
So you basically described this as how we define FMEDA, we read it into something else.
Yes.
What do we do output of that tool? Does it go back to this FMEDA file, or it's a back and forth?
I mean, you could, right? So you can start. So you could, let's say, you have your FMEDA tool, right. You do your definition, you write this language, then you can give it to somebody else. They do the integration in different IPs, and then it comes back as an SOC level, just as an example, right? But the point is, this is capturing just the FMEDA for now. So yes, you can go back and forth in between tools and integrate and so on, but it's always focusing on an FMEDA.
Let me say it differently. Requirement tracking. I read the FMEDA and I put my requirement IDs in there now.
Yes.
I don't want to lose that. If I go back to the tool, I have to make sure my requirements are not lost.
Okay. So the way we have it in the data model right now, you would define a custom attribute that you can say, hey, this is my requirement ID. And that will be preserved as you go in and out. We don't have a special treatment by saying, hey, this is an ID of a requirement, because we don't know what to do with it right now. Right. So everything that has a special meaning, for example, for calculating a metric, for implying something else in the flow, we defined an attribute. Everything that is just information annotation, you can define a custom attribute, which means we store it. We don't do anything with it. It's like think about of any other tool that allows you for anything, not just FMEDA. You can define a custom attribute. The tools won't be able to know what it is, but they will keep it for you.
I see.
So that's the same here. So for your requirement IDs, yes, you can annotate it. Now, I don't know if those are updated dynamically from an external tool. We are doing nothing with it except storing it in this data model. Right. Does it make sense? You see what I'm saying here?
It makes sense, like in metadata, and you keep it, and later on the tool can use it later if it wants to.
Now, if that had a special meaning and it was updated somewhere else, hey, we just kept what you gave. There is no connection, right?
Right.
Yeah.
Right. Thank
You talked about traceability of data model development, slide 18. I didn't quite understand what you meant by traceability.
Yes.
Is that just a mapping from, parallelograms to blue object boxes? Or?
It took us a lot of work. Don't just say mapping of parallelograms. But yes, it is what it is. So the point I was trying to make here is really that we started from defining, okay, what are the steps you need for an FMEDA? Okay, these are the objects that are implied in this processing. What I'm doing is making sure that every object in here is represented in my data model. I have some requirements, and this is my implementation of the requirements. That's what I was told by a person that knows model-based system engineering. That he told me, he's like, hey, you are really defining requirements and implementing them. My answer was like, oh, if you say so, well, that's great. But we did it instinctively to say, hey, why am I defining things? It's because I need them somewhere. How do I prove I need them? That's why we spend time on this, okay? To say this is everything we need. And it's a high level, then I have to have all the attributes. But this is everything I need. Do we all agree on this? And in fact, we haven't changed this entity type at a high level for a long time. The attributes, yes, we're going back and forth. But this hasn't changed. So when I say traceability is really that once we have all agreed that this is what I need to do an FMEDA, you can see I just write down everything in here. And here's my data model. Do you see the value? Because it was very beautiful to me.
So traceability, it's kind of an overloaded term.
Yes.
It's like, is there some kind of dashboard with green and red that shows this is traceable, or is this just kind of an abstract concept that you're using?
I have no green and red, but everything that is here is here.
Okay.
So I don't have a way to say, hey, green and red, but I mean, it's because it's small, and I don't know if there is a better way to do it, but everything that we have described here, it's here. Also here, there is nothing that is in this table but not here. Okay. Right? That's the idea. It's somewhat of an instinctive application of things without really having a system to capture all of this. But when you look at it, it has corresponding connections or traceability. I mean, although it's overloaded, that everything that we described here, it's here, and there is nothing else here that is not here to implement this process. And then the same is for the commands. I have 3 specific rules to take this and translate it into a command. Mm-hmm. So I can, in theory, write a script. And I say write a script is because that means I have rules if I have a script. I'm not doing it manually, right? So everything that is an object is a create, everything that is a relationship is an assign, and everything that is a weak entity is a define. So I have a one-on-one correspondence on how I'm doing things. That's what I mean by traceability. Okay? Implementation and translation.
Got it. Okay, thanks. Yeah. And if you can go back to that object diagram, since you were so deliberate about everything, I was curious, can you talk about the 3 different types of arrows? We got dashed and blue and black.
So the black is, see, the yellow are functions, so to say. So the arrows are function. From here to here, from here to here, I'm doing something. I'm doing an intended functionality analysis. I'm doing a failure mode analysis, a failure mode effect analysis. Now, this one is the function of application, but then the blue is really the concept of mapping. Initially, let me tell you the truth, initially this was done in PowerPoint, okay, with a double arrow that went from here to here. Okay, there wasn't this thing in the middle. So this was just a double arrow that showed that there is a mapping. But the blue, so the black is the function, and then this blue plus gray is actually the mapping idea. So it's not casual, it's not a coincidence, but I don't think it's very self-explanatory. In PowerPoint it was uglier, but it was much more self-explanatory that this was a double arrow, the concept of mapping. Okay, and then this was recreated, I can't remember the name of the tool, but it was recreated more as objects, and then these arrows came about. But yes, thank you.
This is a process to have an FMEDA analysis.
Yes.
And just to understand your languages that you're trying now to build up for all the process that are creating this is used to create this flow.
Yes.
And all the information needs to be stored on this FMEDA analysis, let's say. And the purpose of this, at the end, it is trying to have the same standard to, at the end, have a table of a database of information that you can store and reuse many times on. What is missing still on the language that you think that is still, let's say, not captured by the... Do you think you analyze all?
Hopefully, the language covers at least the FMEDA, the way it's done by the semis, with different ways of doing it. Now, I want to say something because you pointed out something really important. Let me go here. As of today, information is shared in Excel. So first of all, of course, I can write a script, a Python script that parses it. It's every time a pain because everybody has its own FMEDA. There are some templates and everything. The interpretation sometimes is arbitrary and so on. So when I give you this is a nice, easy text file that hopefully once a parser is out and everybody agrees on the language, there's just this. There aren't many tabs in Excel and so on and so forth. What I store might be completely different. It's a DB, potentially, as a tool vendor, but what I exchange is a text file, okay? And the text file, hopefully, as I said, has rules that are much easier rather than an Excel with different tabs, okay? So then there was a secondary distinction, which was, hey, I also have information in this language that is a combination of everything in my tabs and also potential information that you might have, and it's not even in the FMEDA you exchange as XLS. How do you combine safety mechanisms, for example, right? So there could be other information. The idea is this should allow you to recreate an FMEDA in tool vendor 1, tool vendor 2. That's the aim of all of this, okay? Hopefully this covers, and so far we haven't heard anybody saying, so I'll give you another example, okay? When I assign a piece of logic, let's say a part of a Verilog, to a part, what I can do then is do the same for a subpart, and then I can do the same for failure modes. But then what we have seen is some user, they don't do the mapping for the failure modes on the logic. They just do it on the subparts, and then they say, hey, uniformly distribute across all the failure modes. That's one methodology we need to support in here. Another one could be, for example, people don't want to have overlapping subparts. What do we do with that? Custom rules, or do we enforce a rule? So the goal for us doing this validation right now is creating examples. I'm hoping we'll get at least 7 or 8 semis in the team implementing their FMEDA with this language. Because what I want to hear from them is, hey, this language, maybe directly, maybe I have to write 10 more lines, but it allows me to take my FMEDA and exchange it. That's what I call validation. So to see if the use cases, at least from the team, are actually captured. The companies in the team are significant, right? Now, is everybody giving me an FMEDA? Not yet, but we'll pester everybody. But we have NVIDIA, AMD, Qualcomm, Infineon, NXP, ARM. Who else do we have in there? I'm sure I'm forgetting people. Of course, we have the 3-4 vendors, right? So it's significant representation. We just need to make sure that everybody signs off and say, okay, I can do my FMEDA with this. Do I love it? Maybe, maybe not. But I can do what I need to do. Okay? So that's the goal before we actually publish it as a draft, to have at least validation from a few significant set of people that can say, hey, I've done FMEDAs for 5-10 years, and I can actually support it with this. That's a call to action, and it's a bagging, actually. You know, when you see the draft, make sure that you give feedback as well. Thank you very much.